All right, this is Business Cal 4.2, Part 2. And we're going to finish example 6, where we had the ln of x to the fifth minus ln x cubed. So if we combine that, subtraction, it combines to division. So I have ln of x to the fifth divided by x cubed, which would simplify to ln of x squared. And again, by taking and either expanding the logarithm or combining the logarithm, what's going to happen is we're going to make it a problem that's going to be easier to find the derivative of when we get into derivatives in the next couple of sections. All right, so now let's talk about how else we can use logarithms. All right, so if we're doubling under compound interest, so how soon will money invested at compound interest double in value? And so the solution to this question makes important use of the property ln m to the p equals p ln m. So in other words, logs bring down that exponent, okay? So a sum is invested at 12% interest compounded quarterly, and we want to know how soon will it double in value. So what we're going to do is we're going to start with that formula. We know our final amount is P times 1 plus R over N to the NT. All right, where that the A here, that final amount, we want it to be double the original. So I'm going to change that A to 2P equal to P. So it doesn't matter what that original value is. We'll be able to tell no matter how much I put in, how long will it take to double. Okay? Now let's fill in the rest of it. We have 1 plus 0.12 divided by 4, because remember quarterly would be 4, raised to the 4t. And again, I don't have a value for t because I want to know how long or how soon. That's our t. How soon will it double? All right. So what you want to do is you want to simplify the inside that parenthesis. So by simplifying the 1 plus 0.12 divided by 4, we end up with 2p equal to p times 1.03 all to the 4t power. That needs to be one of the very first things you do. Then we're going to divide by p on both sides. Okay, that's an extra variable that we don't need, and we see that it cancels out. So we see that it cancels. So what we end up with is 2 equal to 1.03 to the 4t power. Well, I don't know how to solve this without using logarithms. If you remember from college algebra, to solve a logarithmic equation, I'm going to take the ln of both sides. Or to solve an exponential equation where we cannot get the same base, we take the ln of both sides. So I'm going to have the ln of 2 equal to the ln of 1.03 to the 4t power. Okay? And we're going to use that property that says the powers come to the front. So I have the ln of 2 equals 4t times the ln of 1.03. And then I'm going to solve for t. That's the goal, to get this t. Oh, sorry. Let's try this again. Not sure why this is doing that. To get t by itself. So I'm going to divide by 4 ln of 1.03. And you can do that on both sides. And when we divide that, I'm going to pause for just a second. I want you to plug that in your calculator and get an answer, and we'll come back and compare. All right, if you plug that in, you should get 23.4. And remember, for this equation, time is always in years, so it'll be about 23.4 years. So it doesn't matter how much money you put into the account. Under these circumstances, if it's 12% interest compounded quarterly, it's going to take about 23 years for your money to double. Okay? We can do the same thing again with example 10. So it says a sum is invested at 15% compounded continuously. How soon will it triple? Okay? Remember the original formula is A equals PE to the RT. If we're going to triple our amount, that A becomes 3P equal PE to the RT. Actually, we have Okay, I think I've got it working. So that E is, our R is 0.15 T. All right, so same concept. We're going to divide both sides by P to clear that. And we need to find the value that makes the statement 3 equals E to the 0.15 T true. So we're going to take the ln of both sides again. So I'd have ln of 3 equals ln of E to the 0.15 T. And we're going to use that power rule again that pulls the exponent out front. So ln of 3 equals 0.15 T ln of E. And then ln of E, if you recall from our properties early on, that's equal to 1. So it goes away. So when I'm going to divide, the only thing I have to divide by is the 0.15. So take a second and plug that in your calculator. And when you do, you should get 7.3. And again, that would be in years. So under these circumstances, for our money to triple, no matter how much we put in there, it's going to take about 7.3 years. All right, let's keep going. All right, so the next way that we can use logarithmic functions is to talk about drug dosage. So the amount of a drug that remains in a person's bloodstream decreases exponentially with time. If the initial concentration is C, which is milligrams per milliliter of blood, the concentration T hours will be this formula. C of T equals C times E to the negative KT, where the absorption constant, or that K, measures how rapidly the drug is absorbed into the body. Okay? Well, every medicine has a minimum concentration below which it's not effective. If the concentration falls to this level, another dose should be administered. So what happens if you look at slide 18 is you'll take the dose and then it'll start to wear off. That time where it hits that minimum effective concentration is when you should take another dose. So you get the full dose again and then it wears off. And that continues, that pattern continues. So what we're going to be able to do is take and find what is that time period that the medicine should be taken. So the problem is to determine the time T at which the dose should be repeated so as to maintain an effective concentration. In order to do that, we want to use this formula, that C of T equals CE to the negative KT. Okay? So, looking at example 11, It says the absorption constant for penicillin is K equals 0.11, and the minimum effective concentration is 2 milligrams. If the original concentration is C equal to 5 milligrams, find when another dose should be administered in order to maintain an effective concentration. So we're looking for that T value. So if we plug everything in, that minimum effective concentration right here is going to be our C of T. So I've got 2 equal to 5 times e to the negative 0.11 T. All right. Now, anytime we're going to we need to solve for the exponent, we know that we're going to take the ln of both sides, but in order to do that, we need to get whatever's raised to the power by itself first. So I'm going to divide by 5. So I have 2/5 equals e to the negative 0.11 T. Then we can take the ln of both sides because we have that e by itself. Okay, we have to have that by itself first before you can take the ln. When you take the ln, we've got the ln of 2/5 equal to the ln of e to the negative 0.11 T. We know the right-hand side of that equation becomes negative 0.11 T. And then to solve for T, we can divide by negative 0.11. When you're plugging this in your calculator, you want to make sure that you have ln of 2/5 in parentheses, making sure you're closing your parenthesis after that 5, then divide, then negative 0.11. So plug this in your calculator just to make sure you're going to get the same answer that I do. And we should get 8.3 equal to T. So about every 8 hours, or 8.3 hours. And if you look at the next slide on 21, here's a graph of what that would look like. All right, so in the next video, we're going to start with carbon-14 dating and just talk about some more applications of logarithms.